Good morning everybody. In this video lecture we are covering the selection and insertion sort through Python. Okay, this is the topic of unit 5 of Python programming. What is selection sort? Okay, first of all, before understanding selection sort, we try to find out the meaning of what is the meaning of sort. Sorting is to arrange the elements, whether they are integer or whether they are float values or whether they are strings, in some order. Then it is known as the sorter. Then it is known as the sorting. If we are arranging the elements in ascending order, then it is known as the sorting. And if we are arranging the elements in descending order, then it is known as the you can say this is known as the reverse sorting. Okay, just arranging the elements in ascending or descending order can typically be known as sorting, but arranging the elements in descending order is mostly known as reverse sorting. Because if we talk about the sorting of elements, then basically we see that if we sort the elements in ascending order, because the arranging is basically done in ascending order, that's why it is known as the sorting. Okay, normally if you have to sort the numbers, you just arrange in increasing order, never you arrange in decreasing order. That's why sorting term is basically used for arranging the elements in ascending order, and if we are arranging the elements in descending order, then it is known as the reverse sorting. Okay, now talking about doing by selection sort, it is basically the simplest strategy is to search the entire list for the position of the smallest element. The simplest strategy is to search the entire list for the position of the smallest element. If that position does not equal the first position, the algorithm swaps the item at those positions. That is, the working of selection sort is very simple. The word which mainly works here is known as a selection. The selection word stands for arranging the elements, or you can say it stands for selecting the minimum element or the smallest element from the list of the given elements, and then if that element is not present at the very first index number, then we swap it with the very first index value, and in this way the smallest element gets arranged or gets sorted at the first index value. Okay, it then returns to the second position and repeats this process again and again, swapping the smallest item with the item at the second position if necessary. When the algorithm reaches the last position in this overall process, the list is sorted. Okay, the algorithm is called selection sort because each pass through the main loop selects a single item to be moved. Okay, selection because in each pass the one item is selected, which is the smallest element of the total array, and that element is arranged at the first position. In the second smallest element is searched from the remaining array, and then it is arranged in the ascending order. Okay, in this way the selection sort works, and in each pass what it is doing that the smallest element get at the first position, the second smallest element gets at the second position, and in this way the whole array or the whole list get sorted. Okay, now we can understand it working from how this is working. For example, let's say if this is the unsorted list which is given to us. Okay, this is the unsorted list which is given to us and we have to arrange. Then how selection sort working? Selection sort is working in the way that in the first pass it is finding the smallest element of the whole array available. The smallest element of the whole array available. And if you see this whole array, you find that the smallest element of the whole array is 1. Okay, the smallest element of this whole array is 1. Then what it is doing? It swaps the value of 1 with 5. Listen carefully. It swaps the value of 1 with the value 5. That is 5 and 1 get interchanged. See in the after first pass figure you see that 1 has moved here and 5 has moved here. You see, in this way the first pass is over, and you see that the first element is get sorted. Okay, the first element gets sorted, and the remaining elements are now 3, 5, 2 and 4. Okay, in second pass what is happening? In second pass what is happening? It is seeing the second smallest element from the given list of the elements. Okay, it sees that 3, 5, 2, 4 are available here. 3, 5, 2, 4 are available, and one has been sorted. Okay, one has come at its right position where it should come after the sorting, and the remaining 3, 5, 2, 4, it finds that which is the next smallest element, and here you see the next smallest element is 2. Then in the remaining portion, which is not gray, which is white, the 2 is swapped with the value 3. The 2 is swapped with the value 3, and in this way the second element get sorted. Okay, you see the figure after second pass is coming is that 2 has moved to this position and 3 has taken the position of 2. Okay, you see the asterisk mark here. In this way the two elements are sorted. Till now you are getting my point that in selection what we are trying to do, we are selecting the smallest element from the remaining array and swapping it with the index number which is just comes after the element sorted. Okay, you see when the two elements are sorted, then the next element will be sorted will come at the index number, you can say third index number. Okay, now after in the third pass what is saying, it is again finding the next smallest element from the given list. The next smallest element you see is the 3. It swaps 3 with the 5. 5 come here and 3 comes here, and in this way the three elements get sorted. Okay, next it finds again smallest element, which is the 4. It swaps 4 with the 5, and in this way the whole array gets sorted, because when two elements are remaining, when 4 takes its position, then 5 automatically comes its original position. In this way after fourth pass you see that all the 5 elements get sorted. Okay, this is simply a trace of the data during a selection sort. Passes which comes through the outer loop. When we see the algorithm, you will see that the passes which comes after the working of the outer iteration or outer loop when we are working. Okay, in this way the selection sort are working. Now in programming case, how you will be doing, just simplify it. Okay, you will be given a list. The first step is simply applying linear search, find the smallest element from the given list. One will be available to you. After that, swap it with the 0th index value. Okay, it will be swapped with the 5, then the figure will come to like this. Again repeat the loop, find the next smallest element from the remaining list, that will be 2. Swap it with 3, this list will come, and repeat this process continuously. Basically there are two steps. First is the selection of the smallest element from the remaining list, and the second step is swapping it with the next smallest position available after the sorted elements comes after that index where the sorted elements have been placed. Okay, after that index, that very next index, the element will be sorted. Okay, now see the working of the algorithm. Okay, here we will see, you are seeing the program of selection sort. Okay, here you will see that in the selection sort what we are doing, that we have considered a list. Here you see with the name A, and the list are having the 5 elements 2, 1, 3, 4 and 0. Okay, and let's say we have passed this list in the selection sort with the name A, and here we have written the procedure for the selection sort. Okay, you see we written the procedure for selection sort, and in this way the list A which is passed here will be stored in the variable list, and through this we are working on the list. Okay, there will be, we are getting the 5 elements, and these will be like that. The original list will contain 2, then it will contain 1, then it will contain 3, then it contain 4, then it contain 0. Okay, and the index number for the index number for these elements will be, and this will be the index number 0, this will be the index number 1, this will be the index number 2, this will be the index number 3, this will be the index number 4. Okay, now what we are trying to say that now in the selection sort, what I told you in the selection, first we are finding the minimum element. Okay, not finding the minimum element, we are finding the minimum element from the list, and we are storing its index number in the variable with the name min index. We are using here the variable with the name min index, which is storing the index number of that element, which is the smallest in the given list. Okay, for that initially we have initialized a variable with the name I, whose value is 0. Okay, whose value is 0, and we are comparing the value of I with the length of list minus 1. That is, we are comparing the elements with the total element of the list. And if we want to check, and initially we have placed in the minimum index value the ith index number. Okay, that is, initially the minimum index number is 0. Initially the minimum index number is this. Now what we are doing, we have are declaring a variable j, which is acting as a loop counter, as a counter variable, which is incrementing the index number from 1 to 4, and we are comparing it with the minimum index value. We are comparing the jth index value with the minimum index value, and if the jth index value is smaller than the minimum index value, then in the minimum index we are moving the jth index. See, for that we have written this logic. Okay, here we are comparing the while j is less than this, we are comparing the, if the jth index value in the list is less than the minimum index value in the list, if this condition becomes true, then the minimum index number becomes j, and we are increasing the value of j by 1, and again the loop is working, and in this way the whole loop continues till we find the overall smallest element from the list. And here the overall smallest element is 1 with the index number 1, and hence in the minimum index we will get the value of j as 1. Okay, now if the minimum index number which we are getting is not equal to ith index number, here I is initially 0, if both values are not equal, it means that we can swap them, that is, the minimum element is not present at the 0th index value, hence we apply the swapping concept. And when we apply the swapping concept, what will happen? We are using simply the concept using third variable, and when we use the third variable concept, then initially when the first iteration of first pass complete, the 1 will come here, the 2 will come here, the 3 will come here, the 4 will come here, and 0 will come here. Okay, and you will see that the first element get sorted. Okay, after that this loop will this loop will increment the value of by 1. You see, the value of I is incremented by 1, and this is passed to the outer loop. This is passed to the outer while loop, and again with starting from this, the working continues till the end, and the second minimum value will be found. As second minimum value is 2 and it is placed at the original index number where it should come, no swapping will be performed. Okay, swapping will be performed only when this minimum index number is not equal to ith index number. In this way the selection sort continues, and finally the overall all the elements will get sorted. Okay, the output is shown in the next slide. You will see the element 2, 1, 3, 4, 0 are sorted in the next slide. The output is, you will see here is, the output you get is 0, 1, 2, 3 and 4. In this way selection sort works. Okay, I think you have got the concept clear. The running time of selection sort, if you see, because in each iteration it compares with all elements. So the running time you see in the first iterator, it compares with the n minus 1 elements. Okay. Second time it compares with n minus 2 elements. Overall you will see that in the last it will compare with one element. Okay, or you can say approximately it is comparing with the n elements. Okay, so if you calculate the running time of insertion sort, the overall running time will come out in the worst case is of order of n square. Okay, in this way the selection sort works. Now we will discuss the insertion sort here. Okay, next slide. What is insertion sort? Okay, insertion sort is also one of the technique which is used to sort the elements in ascending order, but it is different from selection sort. In the selection sort, we were selecting the smallest element, fixing it at the position 1, then we are finding the next smallest element, fixing it at the position 2. But in the insertion sort, we are inserting the jth index element in the previously sorted array. Okay, that is there is something what we are insertion sort, we can say that the elements on which we are working, that is if we are working on the jth index value, then the elements before that index, that is till j minus 1 elements, are already sorted in that position, in those positions only. Okay, and in that we are inserting this element and the element gets sorted. This is what sort the jth index value. Okay, for jth index value, that is if we are working, let's say we are having a list and we have to sort the list, we have to insert the sort the element jth index value of that list. Okay, let's say this is the jth index value of that list. Then what it does mean that the array A will contain index number 1, will contain index number 1 to index number j minus 1, that is to index number j minus 1 element in sorted order. That is, it contains the values index number a1 to j minus 1 in sorted order in the given list. Okay, and that we are inserting the element j. Now just see here, another algorithm called an insertion sort attempts to exploit the partial ordering of the list in a different way. The strategy is as follows. On the ith pass through the list, when we are doing the ith pass through the list, where I ranges from 1 to n minus 1, if the I is the range from 1 to 1, the ith item should be inserted into its proper place among the first I items in the list. That is, we are inserting the ith item into the inserted into the proper place with the first I items in the list. Okay, after the ith pass, the first I item should be in the sorted order. That is, the first I items will be in the sorted order. This process is analogous to the way in which many people organize playing cards in their hands. Okay, that is, if you hold the first I minus 1 cards in order, you pick the ith card and compare it to these cards until its proper spot is found. Okay, and as with our other sort algorithms, insertion sort consists of two loops. Okay, the outer loop traverses the positions from 1 to n minus 1. From each position I in this loop, you save the item and start the inner loop at position I minus 1. Okay, we are basically, the outer loop is for the position, and for each position I, we save the item and start the inner loop. Okay, for each position you can say j in the loop, you move the item to position j minus 1 until you find the insertion point from the ith item. Okay, how it is working, just see. For example, if this is the unsorted list given 2 5 1 4 3, then we assume that if there is only one element in the insertion sort, then it will be already in the sorted order. Okay, it will be already in the sorted order. Okay, after that, if in this list the next element comes find, that is no inserted, it is not inserted, then when the next element 5 comes, then we compare it with the element 2. As it is greater than 2, then these two elements will be sorted in these positions only, and the next element 1 will come. Okay, just see here, when 1 is coming, we are saying that the previous two elements are sorted in those positions only, and their positions is not here, their position not interchanged, as they are already in ascending order. But when 1 comes, then we are inserting the 1 in the already sorted array. Okay, already sorted list, sorry. Okay, and that is first we compare 1 with 5, as 5 is greater than 1, 5 will come in the position of 1. Then we compare 1 with 2, as 2 is greater than 1, 2 is moved to the next position, that is at the position of the 5. Here the 2 will come, and 1 will move at the 0th index. In this way the three elements get sorted. Okay, what I have said is that when we have worked till index number 2, you will see that all the three elements are those elements which were already in this list, but now they are in sorted order. They were in this list only, but now they are in the sorted order. Okay, when we are inserting the 4 next element, this list is already sorted order. As this list is already in sorted order, then the comparison becomes less. For example, first we will compare 4 with 5. As 5 is greater than 4, 5 will come at the position of 4. When we compare 4 with 2, as 2 is smaller than 4, 2 will not be shifted, hence the position remaining for 4 is this position only. That is, at the position of 5, the 4 will come and the 4 element will be sorted. After that, you will see that when the value of 3 is coming, when the value of 3 is coming, 5 will be shifted to a position of 3, 4 will be shifted to a position of 5, and 3 will come at this position. In this way, all the elements get sorted. That is what insertion sort is doing. It is sorting the elements of the list. That is when we are working on a particular index value, the previous index's values are already sorted in that place only. That way it is sometimes called as in-place sorting. Okay. Now, if we see this is the program for insertion sort. For example, this is the array which we have to sort, and we have passed in the insertion sort function. Okay, here also what we are doing serial working, we have first given the index number 1 to I, and we are comparing if I is less than the length of the list. If I is less than the length of the list, then we want to insert the item to the list of I. We are comparing if j is equal to I minus 1. If j is greater than or equal to 0, then item to insert is less than list of j, then list of j plus 1. That is, we are swapping, that is, we are comparing, we are shifting the value to the, that is what we are trying to do here is that first we are checking if I is less than the length of list. If it is true, then we are inserting the ith element to the list. Okay. Again, now when we are inserting the I, for example, we take the I value of I is 1, that is, we are working on the value 1. Okay, value 1 at index number 1, and the item to insert is value 1, and we have to compare it with the previous index value. That is, we are comparing with the value of j until the value of j is greater than or equal to 0, and the item to be inserted is smaller than the list of j. Then we are shifting the jth value to the j plus 1, sorry, jth value to the j plus 1 index number. That is, we are shifting the 2 1 to the right, and this way we are decreasing the value of j by 1, and we are continuing this loop until the elements which are larger than the element on which we have to fix at the right position. We get all the elements larger, we are shifting those, and when we get the right position, we move it. In this way, we move that element to the correct position, and in this way you can work on the insertion sort. I think you have got the concept clear. It is simple, short, and this is the output of the insertion sort. You see 0 1 2 3 and 4. and in the next video we will cover about merge sort and higher order functions. Thank you very much.